All right. All right, but again, thank you for those who are at home tuning in. I know it's kind of a hassle, but I think for us this kind of works. I don't know. Maybe it doesn't. I don't know. I kind of like it, but I'd rather have people in person. It's way easier. All right, but reminder for those who are here, thanks for being here. I know that it's kind of tough learning at home. I try to make it as easy on you as possible. I don't try to make it overly difficult, I don't think, but it's one of those things that I do want. If you're not in class, let's say you're sick, you're at home, you're distant learning from home that day because we're in the hybrid plan, do Zoom in every day, because that's how I take attendance. If you're not Zooming in, I do count you absent unless you've talked to me ahead of time and we've worked out a schedule for you, okay? So keep that in mind. So thanks for those who are at home that are tuning in. It makes it a lot easier on you and me for getting things done. All right, we're just going to take a few notes today. As you can see, we've been doing Elimination Method. That was the homework that was due yesterday. Last night we had a worksheet 2.8 due. It was due at 11:59 last night. And then we've been working on substitution since, I think we introduced it, Tuesday maybe? We introduced the first substitution problem on Tuesday. We're going to work on a couple of them today, and then we have to talk about some special cases today. That's my last two types of problems. I have 3 slides that I want to go through today. 3 slides. The first slide is reviewing that Google form questions that I had yesterday, just to make sure you know what the answers are. And then we have 2 more slides after that. So there's technically, I have like 3 problems. I'll put that in air quotes because there's 3 types of problems I want to walk through. So hopefully that makes sense to you. That's what I want to go through. I want to take some easy notes when we're finished. We're finished today. Nice and easy. I don't want to give you any homework. You've been probably stressed out of your mind, out of all the stuff going on for homework and stuff. For us, we're very, very, very quickly approaching the end of our chapter. Like, really close to the end of the chapter. We have 1 section left after this one. So we'll probably get that one on Monday and Tuesday, and then we have a test next Friday. So that's kind of what I'm expecting, a week from tomorrow. So you'll probably get a practice guide probably as early as Monday. I'll probably send it to everyone via Google Classroom, but then when you're in class, I'll give you a physical copy. So keep that in mind. Maybe if I can, maybe I can get them printed. I can give you guys your physical copy tomorrow. That way you're not waiting till Thursday to physically get it. So that'd be kind of nice. So I'll try my best to print those out for you guys. But for those at home, I'll just send it out via Google Classroom. Test will be kind of interesting. I don't know how I want to do this. We need to take a test, and I'd rather have you here in person so you can ask questions, but it's not possible with the hybrid that we're going to be in. So I'm expecting we'll be in hybrid, but I can't make assumptions. I can't spread rumors or anything like that. So I don't know. Every week is kind of different, so it's kind of weird. But yeah, let's do a couple notes here. All right, let's just jump right in. All right, so systems of equations, we've been doing substitution and elimination method, and I basically just want to talk about kind of what we're going into. So we had homework due yesterday. That was due yesterday. So if you did not get that homework done, it's late. Get it turned in. All right, let's jump right in. So these are the 3 problems I submitted to you on your Google Classroom. You probably looked at this. I had a picture there, and I also had a document. I don't know which one you ever click on. It doesn't really matter, as long as you can open it and see it. I always try to give a picture in case like you're on a personal computer at home and it doesn't like a Word document. I like to have a picture there so you can open up a picture instead. If you're ever having issues opening them, sometimes on Google Classroom, it'll allow you to use a different app to open them. You can choose the app from the App Store to open them with. So that might be something you want to think about if you're struggling opening any documents. But I always include both. I think most of the time, most people just click on the picture one. That's fine. I always try to have both for you. Okay, so again, we're going to be finding the solution for the system using substitution. That was the problem. So we want to kind of work on substitution methods. So if we look at what we have here, as you can see, this top problem, I'm going to go through each of these kind of one at a time here. So this top problem, this is the letter that's by itself, and so I'm taking this y plus 2, or the 2 plus y, and I'm plugging that into the other equation. Because how I identify substitution method, if the letter's by itself, that's what I'm substituting in for. So on that top line, I'm taking out the X, because that was the letter that was by itself in that second line. And I'm plugging in that 2 plus y to where the x is, because they said all x's are 2 plus y's. Does that make sense how I'm substituting that in? Take out that letter in that top equation with what they say it's supposed to be equal to. And then you just do some simple algebra, right? We distribute the 8 through, multiply it on both, so that's 16 plus 8y plus 2y. And then you just solve from here, right? So I would subtract the 16 across. So if I subtract that over, this equals 10y is equal to negative 10, because it would be 6 minus 16. And then I divide both sides by a 10, and my y turns out to be a negative 1. That's odd. Let me write the 1. Okay. So I get negative 1. And then what you want to do is plug that back in. And what I always recommended is when you take that number, you want to plug it back into the equation that we identified, that we said was by itself, right? So the x plus 2y, or the x is equal to 2 plus y. You want to plug that negative 1 into that y there. So this ends up just being 1 for the x. So your coordinate for this one, if I write that down, so for that first one, you should have had 1 comma negative 1. So, questions on how I did that? That was kind of the Google form question that we had yesterday. So hopefully you had that submitted. I kind of looked at them yesterday, kind of seen. I really was just kind of checking at first, because I know a lot of you were online kind of working on it and whatnot. And what I was checking for is just to see how many people paid attention to the directions I said. And I caught a ton of people. The thing that I noticed the most was people didn't read the directions. They just submitted the answer we did in class. Like the one problem. They're like, oh, just submit the problem question. And then they submitted their question and then they zoomed out, right? But they didn't answer these three, because they never opened it. They didn't see the documents at the bottom that I said answer the 3 questions on the questions below. They didn't see that. They just thought, do what we've done the last 5 days in here, where you just submit the question we've done in class every day, right? So it made me laugh. I knew it was going to happen, and I caught those people, and I emailed them like, hey, you need to go resubmit your homework, or the Google question, because you never read it. And then they came back and they submitted them correctly. But yeah, it was kind of funny. I was expecting it yesterday, so I was kind of keeping a track of that when you guys were working. All right, let's go through the next one. Oh, I should not erase that. I should probably take a screenshot of that before I start erasing. Okay. Now let's erase that. Okay, let's do the next one. I'm gonna leave that first answer up there. I think it's important you guys get to see that. Okay, so the next problem here. The y is by itself, and this is the part that I'm going to plug into that other equation. I'm going to plug that 10 minus x in, and it's going into the y location, because the letter that's by itself is the letter that you're taking out. So on that top line, I'm taking out the y and plugging in the 10 minus x into it. Again, how I know where to plug it in is the letter that's by itself is the letter you're taking out of the top line. That's how I identify it. The y is equal to 10 minus x. So then I would distribute. Well, this is just a 1. Distributing a 1 really doesn't do anything. So that's 3x plus 10 minus 1x. Distributing a 1 doesn't really change anything. And then combining like terms, moving things around. If I move that 10 across, so subtract. So it becomes a 4 over there. And this 3x minus 1x is a 2x. So my x turns out to be a 2 when I actually solve it. Now, what do we do with the 2? Plug it back in, and always plug it into the part that I circled, the part that I identified the letter that was by itself, right? That's the equation you want to plug back into. So I'm going to go to that equation. That's the y equals 10 minus x, and I'm taking out the x and plugging a 2 in there. And then this turns out to be an 8. Perfect. Okay. Welcome, Alexis. Thanks for tuning in. All right, but yeah, there's our next one, right? So let's get rid of those. So it's that second problem. So it ended up being a 2 and an 8. And now the third problem. The third problem from the Google form, and this is not the Google question of the day today. I'll get to that here in a minute. This is just the first slide out of 3 slides I want to go through. These are just the Google questions we had yesterday. So on this next one, they have an x by itself. So I'm going to replace all the x's with a 3 minus 4, or 3y minus 4. So in that top line, taking out the x in that top line, I'm going to replace it with a 3y minus 4. I don't have to distribute anything into it. There's just a 1 out front technically. So this would be a 3y minus 4 plus 5y equals 12, right? Because there's a 1 here and I distribute the 1. So this ends up being, if I subtract that, or if I add the 4 across, I'll get 16 over there, and I have an 8y on this side. So my y ends up being a 2. If I divide that last thing by a 8. And then what I'll do is I'll plug it back in. So I'll take that y and plug it back into that equation. So I'm plugging that 2 back into the y into one of those top equations. So this ends up being 6 minus 4, which ends up being 2. So your solution to this one ends up being 2 comma 2. Questions with any of the Google form problems that we did yesterday? I think it's important we get to see those. I threw them out there. You're getting points for it. It was an in-class activity yesterday, so you're getting points for that, for doing it. If you didn't do it, you don't get points. That's how easy it is. I usually like to do those once a week. We're going to continue to do that even in hybrid. Maybe I'll make Wednesdays a day where we just kind of do an in-class activity like that. All right. Let's jump to our next slide here. So hopefully everyone's kind of still following with me. I haven't lost anyone yet. We need to talk about some special cases, some stuff that we need to identify. So it's one of those things like it's kind of important we get to see this. So so here we go. This is the first problem. We can do this by elimination. You can do it by substitution. It doesn't matter. Maybe I'll do like one of each just so you can see this. So let's make this problem an elimination problem. I know we did this the last assignment that was due yesterday, like last night we had that assignment due, right? Let's do an elimination problem, but I want to talk about special cases. So I'm going to put that at the top. This is a special case of a problem. I'll explain that here in a second. A lot of people don't understand. Sorry, I got a private chat. I'm still trying to interpret what that meant. Hey, I'll answer your question here in a minute. Sorry. I'll have to read that over again. All right. All right, so elimination method, we're going to do a special case here. And it's one of those things like you just need to see one of these to understand what's going to happen. So here we go. Let me just write down a problem here. We're going to go with x plus 3y is equal to, let's say 8. And let's go with 6y plus 2x is equal to 10. Okay, and I'll draw a line here. All right, so what method should we use on this problem? Wrote it up above. What method are we using? Elimination. The reason why they don't have a letter by itself. Now you could rearrange this thing and make it a substitution problem. We don't have to. So the idea is that we're doing for the elimination method, we want to stack them. We want to get them to, to that form where it's, ax plus by is equal to c. That's standard form. That's the form I want to get it into. So on that bottom line, so this is the top line. I'm going to leave that one alone. It has the ax, right? That's a 1x plus by is equal to c. But on the bottom line, I need to rearrange it. I just like to get the x, y's, and numbers lined up. Okay, now on elimination method, you had to pick one of your letters. What letter should we pick? You're going to pick x's? Okay, let's do that. So we're going to pick x's. Didn't matter. So we want to make these the same digit. So what do we want to make our x's? We make them what? Twos, fours, sixes, eights, anything? We'll make them twos. I'll multiply the top row by 2. So I get 2x plus 6y is equal to 16, right? That's multiplying a 2 through the whole top line. The second line's already a 2, so I'm going to leave it alone. All right. And then we need to make one of them negative, since one of them isn't negative. So I'll make that, maybe I'll make that second row negative. So I switched all the signs, because you only have to do that if they're not negative already. If one of the variable that you chose isn't negative. So I add straight down, and what I'm going to get here is I'm going to get 0, 0, and a 6, right? Because this eliminated, that eliminated, and I have a 6 on the other side. Is 0 plus 0 equal to 6? No. This problem doesn't have a solution. There's no answer to this problem. That's something I don't think we've ever discussed. This is a first time. This can happen in elimination. This can happen in substitution. It can happen in graphing. These things didn't cross. And that's the weird thing. They didn't cross at all. So, in fact, the reason why they don't cross is because of the graph when you look at it. There's a way to identify when it's going to be a no solution or not, but I want you to see this, right? This is a special case where there isn't an answer that works in this problem for both equations for the system. In fact, let's actually look at the drawing of this thing, just so you can see this. I'm going to write down those problems again. Can somebody tell me what the top one was? It was what? X plus 3y is equal to, was it 10? What was that?
It was 8.
8? And what was that second line? It was 2x plus 6y is equal to 10? Okay. Is that it? That was it? Okay. All right. I'm going to graph these just so you can see them. So I'll put the top one, maybe I'll put the top one in red here. Okay, so I'll put the top one in red. So I need to rearrange it. We'll go back to kind of reviewing, graphing. Again, this is not required when you do get a special case. I just want you to see why it doesn't have a solution. So the top line, I'm going to rearrange this. So I need to move that x across, right? We haven't done this stuff since, what, last week? Actually graphing. So moving the x over, dividing everything by 3. So I get negative 1 over 3x plus 8 over 3. Right, dividing everything by 3. So now I'm ready to graph here. That decimal in the back, the slope, because it's y equals mx plus b. So y equals mx plus b. The m is my slope. So I would leave that a fraction. But the 8 divided by 3, what is that, like 2.6? Yeah. So this 8 over 3 in the back, this ends up being this number here, 8 divided by 3. That's 2.6. So I'm going to start at 2.6 on this graph. So 2.6 is about right there. And then my slope, which is this number, this is my slope, that's my m. Since it's negative, it tells me to drop and run. The top number is always up and down. The second number is running to the right. So I'm dropping 1, because that's what the negative means, and then I run 3 to the right. So drop 1, run 3 to the right. 1, 2, 3. Drop 1, run 3 to the right. And you get the idea, and this is what my graph kind of looks like. Oh, gotta erase that. Okay, does that make sense for the first line? Second line, I'll pick a different color. Maybe I'll pick, maybe I'll do the next one in like black or something like that, so you can really kind of tell the differences. All right, so the second one right here, I'm going to do this kind of in a blackish blue color. I'm going to rearrange that one as well, so I'm going to move that, so I'll draw a line here. I'm going to move that 2x over, so it becomes a negative 2x, plus 10. Divide everything by 6, so that's y is equal to negative 2 over 6x plus 10 divided by 6. And 10 divided by 6 on a calculator is, so this number in the back, this number back here is 1.6, right? And then my slope is this. This is my slope number. So I'm going to start at 1.6. That's that number right there. Ooh, I got to put this in black. What am I doing? So I'm starting at 1.6. It's about right there. And then I'm going to drop 2 from there and run 6. So dropping 2, running 6. 1, 2, 3, 4, 5, 6. Drop 2, run 6. 1, 2, 3, 4, 5, 6. What do you notice about these lines? Yeah, you nailed it. They're parallel lines. They don't have a solution. They're literally parallel to each other. So in fact, I'm going to write that right at the top. So that was a really good observation. These are parallel lines. Parallel lines don't have a solution when you graph the system, when you graph both of them, because they never touch. Remember, the whole point of like a solution to a system is like, where do they meet? Right, that point of intersection. I didn't have any. They didn't cross at any point. Maybe it looks like they will, but they won't. If I just keep following my pattern, they follow the same direction. So, now, I did promise you a little bit ago, I'm going to go back to that last slide. I want you to identify, I want you to be able to see the shortcut. I want you to be able to identify the shortcut here on this problem. Here it is. It was right here. It was right at this point. I'm going to highlight it down here. This is the point when you should notice you're not going to have a solution or you'll have another special case. Yeah. Do you notice how the x's matched, the y's matched, but then the numbers on the other side didn't? That's a red flag. They were nearly the same exact equation. The only thing that threw it off was the 16 and the 10 in the back. That's what identified it as a no solution. Because when you actually subtract, they all canceled except for the number in the back. So that's just something that it should be like one of those like red flags when it goes off when you see it. Yeah. So, all right. Let's go to our last slide. So this is the problem for the Google form question. This is my third final slide of the day. We'll be done here in about 2 minutes. That's all it takes. So you have to answer this one. It asks for like, what is the solution to the third problem we're going to do in class? This is technically my third problem. Sorry, I've done a lot more than 3, but this is my third slide that I want to go through. All right, so same thing. We can do any method you like. We can do substitution. Yeah, let's do that. So let's do substitution. It's nice to get some more practice with that type. So we'll do a substitution type of problem. Right? And this will be another special case, because special cases don't just happen on on Elimination Method or anything like that. It happens anytime. So it's just nice to see this get some more practice with this. So so here we go. So let's say that my problem is let's go with y equals 2x plus 4, and the other equation, let's go with, this is 8x equals a negative 4y plus 16. So I'm really throwing in the deep end here on this one. So again, it's a substitution problem. I kind of went way out there. I've got a weird kind of setup here on this problem. Again, it's not the setup that makes it a special case. It's the actual solution that we're going to have here, the answer that you need to fill on your Google form today. All right, so on the top equation, do they have a letter by itself? Yeah, so that's what identifies it as substitution. So they have the y by itself. So this is the mess I'm plugging into the other equation. I'm plugging this in down here, and it's going into the y location down there. So so right in that top line, the second equation, here's the second equation. I'm taking out the letter y, and I'm replacing it with all the stuff that was in that little bubble, the 2x plus 4. Okay, so we plugged it in, right? We do our math. I wonder if I wrote down the problem wrong. I think this actually has a solution. Oh, this isn't a special case. All right, I need to make one correction. I need to make, okay, I need to make a quick fix because I want this to be a special case. Apologies. Ooh, what a mess. Okay, so let's make a quick fix here. Okay, so here's my quick fix. We're going to make that 2 a negative 2. That's all I need to make sure of. Okay. Apologies. So let's make that a negative 2. So when I substitute it in, I'm plugging in a negative 2x. All right. So again, special case, so you can see it with substitution here. And that back number was a 16, right? Okay. Okay, so quick fix, made that negative sign. That's the only flip I had to make. Sorry. I want to make sure this is a special case. I don't want it to be weird. Okay, so does everyone agree that my second line there, I took this equation right here and I took out the y and I plugged in what y was equal to. Okay? All right. So apologies for that. All right, now, doing the math here, let's actually distribute this negative 4 through the parenthesis here. So what we're going to have is we're going to get a here we go. We're going to get, let's go with the green color. I haven't done that one yet. All right, so we're going to get 8x is equal to 8x, because I distribute negative 4 times negative 2 is 8x. Negative 4 times 4 is negative 16 plus 16. So that's distributing the negative 4 through that parenthesis. Now, if we move over the 8x, what happens if I move this 8x over? Yeah, they literally are subtracting, right? And you're absolutely right. They're going to literally cancel. And then I have the negative 16 plus 16 on this side, right? And you're right. I'm going to get, on this left side, I'm going to get 0. They cancel out, right? It made 0. And then on the other side, I get 0. Well, is 0 equal to 0?
Yes.
Yes, it is. This is an infinite solution problem. Anything works. Whatever number you plug in, if it works in one equation, it'll work in the other equation. It's an infinite solution. It didn't matter what pairings you have. The reason why is if you look at the graph, these lines are literally on top of each other. They have an infinite number of solutions to them. So like for instance, on that top line, if I were to plug in, let's say on that top line, that one in blue, the one that I circled up there, if I plugged in a 2 for x, I would get a 0 out for y. Do you agree with that? If I plugged a 2 in for x, I would get a 0 for a y. Right? So that, I'm just guessing at a coordinate here. If I plugged 2 for x, it would spit out a 0 for the y answer. Right? That coordinate would also work down here as well. If I plugged in a 2 in for my x and plugged a 0 for my y, both sides will be equal. And it actually works in both. And I just literally guessed that one. I could have made up another one. Maybe another one would be let's say I said 3 and a -2. Right? Plugged in a 3 in for x, and I'd get a -2 out. If I plug that coordinate in down here, it would also work. I'd plug in a 3 for the x, so I'd get a 24 on the left side. And if I plugged a -2 in for the y, it would give me +8 plus 16, which is 24. So it actually works. So there's an infinite number of solutions. It isn't just one answer. There's an infinite number of them. So that is your other special case. That is the solution. That's the answer I want you to write in your Google form question. What is the answer to the third problem? There it is. It's an infinite solution problem. It's infinite solution. We can plug in anything we wanted. As long as it worked in one equation, it works in the other one. All right, that's it for today. That's all I got. You have about 6-7 minutes here for those online. Thank you for tuning in. You know your answer to the Google form question. You can go log out, go fill it out, and you're done for the day. We have no homework or anything like that. Haley, to answer your question, you want to use to out the right answers. Also, okay, so I understand you guys are home for the 2 weeks. What was the first question again? I didn't understand what you said. What do you want to use?
It was the beginning, so the questions from yesterday.
Oh, those Google form questions?
Yeah, the 3 coordinates.
Yeah. You just submit those 3 coordinates down for the Google form question. That's all you had to do.
Yeah, did you want us to put the right ones, like the
No.
ones?
You don't have to. You don't have to go back. You're getting points anyways for it, even if you got it wrong. I just wanted you to try it yesterday. No,
Right.
good question. Yeah, good question. Now I understand what you're asking. Yeah, that makes sense.
And then, we're out for 2 weeks.
Yeah, that's fine. So, understandable. We'll just do this thing like normal. So, you and your brother can be on the same Zoom if you want. You don't have to be at separate times during the day. So, if he wants to do it in the morning, or if you want to do it in the afternoon with him, you can do that too. So just let me know in the morning. So.
Okay.
Okay, and yeah, if he's there with you or whatnot, just let me know, in the chat, or if you're with him, just let me know too, so then I can get you guys marked down.
Okay, sounds good.
Yeah, all right. See you guys later. Take care of yourself.
Bye.
Yeah, bye.